All right, how to identify an even function algebraically? So what we're going to do, this is mainly what you're going to be doing. You're going to replace x with the opposite of x. What's the opposite of x? Negative x, you got it. So we're going to replace x with the opposite of x, which is negative x, and simplify. If you end up with the same function you started with, it is an even function. All right, can I show you? We're going to do the same example we had that I showed you on the graph. So an example would be f of x equals x squared. So we are going to step 1, replace x with negative x. Do you guys know the W with the slash means with? Yeah, good. W with the slash means with. And then 2, we will simplify. So now I'm going to go to f of negative x. F of negative x would be the whole negative x squared, right? Anytime we see an x, we're going to replace it with negative x. And what happens when you square negative x? Don't you end up with just a positive x squared? So because the original function and the simplified one after we put in the opposite of x is the same, that means it's an even function. If it were different, would it be an even function? No. If it were different, it would not be an even function. Okay, so we talked about even functions. Guess what we're going to talk about now? Odd functions, exactly. All right, for an odd function, all right, the graph of an odd function has rotational symmetry with respect to the origin. Which equals 180-degree rotation. So what does that mean? I'm not going to go into decimals because it stops recording. But let's say I have this function. when we have it 180 degrees about the origin, it's basically just like turning it to 90 degrees. So if I turn this 190 degree, we'd end up in this over here. And then if I turn it another 90 degrees, that would be 180. We would end up with the same exact image over again. So basically, if you rotate it 190 degrees to the left and then another 90 degrees, you'll see that this whole figure moves, it rotates, but then after the second rotation of 90 degrees, that 180 degree rotation, it ends up exactly as it was before. Ends up exactly as it was before. All right, let's talk about algebraically. And this is what you really need to worry about, is the algebraic part. How to show an odd function algebraically. Okay, we're going to replace x with the opposite of x, which we all know is negative x, and simplify. If you have the exact opposite of f of x, it is an odd function. All right, let me give you an example.
Can you go up a little bit?
Oh, sure. Like there?
Yeah.
Okay, so let me give you an example. If I have f of x is equal to x to the third, and I want to figure out, is this an odd function? What you're going to do, step one, replace x with negative x. Step two, simplify. All right, so we're going to have f of negative x means we're going to take negative x to the third power. Does anybody know what's negative x to the third power? Negative x to the third. Exactly. Negative x to the third power is negative x to the third power. So this is negative x times negative x times negative x, right? What's negative 1 times negative 1 times negative 1? Negative 1. X times x times x is x to the third. So our original was x to the third. After we replaced x with negative x, we got negative x to the third. Do we have the complete opposite of our original? Because it's a complete opposite, it is an odd function. Okay, are we ready to do some practice problems? So that's it. Our options are even, odd, or neither. It could be neither one of them, not even, not odd. Anybody still copying this? Okay, so let's do some practice problems. So for all these practice problems, I want you to determine if the function is even, odd, or neither. All right, first one. F of x equals the absolute value of x. So for every problem we're doing, we're taking x and what are we replacing it with? Negative x. So for every problem, when determining if it's even or odd, we're taking x, we're replacing it with negative x, then simplifying. So we're going to go ahead and do this. So now we're replacing f of x with negative x, which means I'm taking that x and putting in a negative. Well, what's the absolute value of a negative number? Isn't it positive? Isn't the absolute value of a negative number positive? So isn't it true if I conclude that f of negative x is the same as the absolute value of x? So since our original and our simplified version are the same, what does that make it? Good. It's the same, therefore. Do you guys know the 3 dots means therefore? 3 dots in the triangle means therefore. Okay, 3 dots in the shape of a triangle means therefore. So same, therefore, even function. All right, let's try another one. All right, f of x is equal to x to the 4th. So no matter what we're doing, we're taking our x, we're negating it, we're giving it the opposite. So we're going to have f of negative x equals negative x to the 4th power. Those teachers or kids?
Probably teachers.
Probably. Okay, what's negative x to the 4th raised to the 4th power? Aaron?
Negative x, no, x cube, not cube, to the 4th.
To the 4th, x to the 4th power. Do you guys know if you take a negative number and raise it to an even power, it's positive, and if you take a negative number to an odd power, it's negative? Did we know that? Good. So if I'm taking negative x to the 4th, it's going to be even. So f of negative x is x to the 4th. So once again, these are the same. So what does that mean? Even. Very good. All right, next one. So let's say I have f of x is equal to x to the 3rd plus x. So now we're going to substitute in our negative x. So now we have f of negative x. That's going to be the negative x raised to the 3rd power minus x. Do we agree? All right, so now f of negative x will be negative x to the 3rd minus x. Can I pull out a negative here, negative x to the 3rd minus x? Can I pull out a GCF of sort of -1? Yeah, I could pull out a negative here. So f of negative x, this is going to be the negation of the whole x to the 3rd plus x. After I pulled out the negative, what is this telling me? This is the negation of this whole thing. Aren't these complete opposites then, if this is the negation of this whole quantity? So what does that mean if they're complete opposites? Is it even, odd, or neither?
Odd.
Odd. Complete opposites are odd. You got it. Nico?
We didn't show that last step. You just did like on a quiz or something where you take points.
I wouldn't take points off. I just need you to recognize that this is the complete opposite of that. As long as you recognize that these two, then you're good. If you need to go that extra step to realize it, then you should. f of x is equal to x to the fourth plus 2x. So now we're going to substitute in that negative x. And when we have negative x to the fourth, that's going to be x to the fourth minus 2x. Look at the first and the last. Are those complete opposites? No, they're not complete opposites. How come they're not complete opposites? This was a plus and this is a minus. How come this is not considered complete opposites? Only Soph knows. Sophia, right? All right, Sophia, tell me.
The x to the fourth power is not negative.
Good. It has to be complete opposites, means every sign has to be opposite. So this was a plus, it changed to the negative, but the x to the fourth didn't change. So these are not complete opposites, and they're not exactly the same. So it can't be even, it can't be odd, so it is neither. All right, last one of these that we're doing. F of x equals 10. What is this telling me? No matter what number I input for x, what am I getting out of it? 10. No matter what number I'm inputting for x, I'm getting a 10 out of it. So what is f of negative x? Still 10. So it's exactly the same, therefore it is even. All right, now we're going to talk about symmetry. So we have different kinds of symmetry. We have symmetry over the x-axis. Let's do y first, over y-axis. So if we're symmetrical over the y-axis, let's see what that means. So if I'm symmetrical over the y-axis, we know the vertical line is the y-axis, meaning I'm going to fold it, and when I fold it, I'm going to create the same image on the other side. So if I have the point 3, 2, what would be its new position if it's symmetric over the y-axis? Same two hands go up every time. So I'm folding it over. I'm creating the mirror image on the other side. Maya?
Negative 3, 2.
You got it, negative 3, 2. So essentially what am I doing when I am reflecting over the y-axis? So this was 3, 2, and this ended up being negative 3, 2. So symmetric to the y-axis, we did what to the x-coordinate? Made it negative, right? Negate it. So what do we do here algebraically? You are going to replace x with negative x and simplify. If it is the same as the original equation, it is symmetric to the y-axis. Okay, let's talk about symmetry over the x-axis. So I'm going to use the same point, 2, 3, 1, 2. I'm using the point 3, 2. But this time, I'm folding it over the x-axis. If I'm folding it over the x-axis, creating a mirror image on the other side, wouldn't my point be down here? So if I'm folding it over the x-axis, my point would be right over here, which is 3, negative 2. What did we do? This time we kept the x the same, and what did we change to the opposite? Charles, right? Y. Yeah. We changed the y. So let's talk about algebraically. We're going to replace this time y with negative y, then simplify. If it is the same as the original equation, it is symmetric to the x-axis.
Oh, are you still learning?
We are.
Oh, okay. Bye, Miss Alvar.
Bye. All right, and our last scenario. You all still copying? I know I'm making you write a lot today. Anybody still copying? Could I go to the next one? Okay, now let's talk about symmetric over the origin. So I'm using the same point, 3, 2. And to be symmetric to the origin, basically you're taking the top corner of your sheet and you're sort of folding it diagonal. So you're sort of folding it diagonal to, oh no, the kids' school are calling me. I'll let them call my husband. Okay, so we're folding it over the origin. So now you're coming over here. So what's happening when I'm taking this point and mirroring it right over here? Not only does the x get negative, but also the y gets negative. So we are then going to be, oops, I plotted this point wrong. I plotted 2, 3. Nobody caught that.
I actually did it. It's insane.
Did I do that on all of them?
No.
No. Okay, just this one. Okay, so 1, 2, 3, 1, 2. So then we would be over here at negative 3, negative 2. So now let's talk about algebraically. What do you guys think we're going to do? So for the x, we negated just, for the y, we negated just the x. For the x, we negated just the y. What do you think for the origin? We're negating both x and y. All right, replace both x and y with the opposites. And simplify. If it is the same as the original equation, it is symmetric to the origin. All right, Perfect. Just enough time to do some problems. Are we ready? We're still copying. All right, I'll let you copy. Okay. We're going to make a little chart. Equation. And you're going to have a chart just like this on the test or the quiz when we get to it. Sim to y-axis, question mark. Sim to x-axis. Or symmetric to the origin. So just to recap, when we're deciding did everybody write this down or not yet? Okay, I'll wait for you. All right, now let's remember, if we're symmetric to the y-axis, we change what to negative? X, Y, or both? If we're symmetric to the y-axis, which one are we changing to negative? X, good. If we're symmetric to the x-axis, which one are we changing to negative? X, Y, or both? Y. And if we're symmetric to the origin, which ones are we changing? X, Y, or both? Both. Oop, this is negative Y. And then negative X, negative Y. Okay. First equation we're going to decide on. Y equals x squared plus 2. So I'm going to test the x-axis, the y-axis, symmetry in the y-axis. So y equals negative x squared plus 2. Do we agree the quantity of negative x raised to the second power is just positive x squared plus 2? Because our original and our simplified version are the same, is it symmetric to the y-axis? Yes. So we write yes in this box. Now we're going to test to see if it's symmetric to the x-axis. So this time I replace y with its negative. So we're at negative y equals x squared plus 2. Well, when you have negative y equals x squared plus 2, I need to get y by itself. So I'm going to divide everything by negative 1. And this is y equals negative x squared minus 2. After I replaced the y and simplified it, is my new version exactly the same as my original? No. So is it symmetric to the y-axis, to the x-axis? No. Right. And the last one, is it symmetric to the origin? Let's see. So this time we're going to replace x and y with the negative. So we are negative y equals negative x squared plus 2. So this is negative y equals positive x squared plus 2, which once again makes it when you divide by negative 1, negative x squared minus 2. Is it the same as the original? No. So this is a no. All right, we're going to do one more problem, then call it a day. Can I go on to the next problem? Anybody still copying? let's do x squared plus y squared equals 4. So when we're symmetric to the y-axis, we're going to replace the x with a negative. So we are negative x squared plus y squared equals 4. So then we're at x squared plus y squared equals 4. Are they the same? Yeah, so is it symmetric to the y-axis? Yes. All right, now we're going to test to see if it's symmetric to the x-axis. So I'm going to now negate the y. Negative y raised to the second power is positive y squared. Is it the same as what we started with? Yes. So this is symmetric to the x-axis and the y-axis. Last thing we're going to test is the origin. So now we're negating both x and y. And when you negate both x and y, we get x squared plus y squared equals 4. Is it the same? Yes. So this one was symmetric to everything. Does anybody know what shape this is? X squared plus y squared equals 4. Not a square, no. That was a good guess, though. Yeah? I heard it.
Circle.
It's a circle. Perfect. It is absolutely a circle. Let me